What's up everyone, welcome back. In today's video we're going to be going through section C, problem 2. If you're just joining us, my name is Yusuf, and if you don't have this question paper, you can get it from the link in my description. So heading straight to it, we can immediately see that we have global variables given for part A, B, and C. So we can head over to SolidWorks right now, put those in. We have global variables A. For part A is going to be 35. B is going to be 80. And C is going to be 1. Okay. Heading back to the PDF. Build this part in SolidWorks. Use the values below for global variables. Okay, so we have a heatsink. So we have an angle of 93 on the sides. Both sides. We have an angle of 87 from the top horizontal downwards. So we're looking at a detailed view of D. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, what happened there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fins. Okay, we have a dimension for the gap at the bottom. We have a dimension for the flat at the top. And we have a depth of the base. Okay, so I think we have everything we need to model it. So let's head to SolidWorks and get going. So we can pattern this, but it's not going to be a normal pattern because of the shape of it. So what we're going to do is we're going to pattern one singular tooth and we're going to ignore the base section for now. So we know that the angle between these two is going to be 93. We know that the angle between those two is going to be 87, which would also give us an angle of 93 at the bottom. And we have a global variable up here of, remember, equals 2, otherwise it won't update when we update our global variables. C. And we have a height of A. So if you select an angled line, holding the dimension close to the line will give you a dimension parallel to the line. If you pull it out in either the horizontal or vertical directions, it'll give you a dimension in those planes. So we have a dimension here of equals to global variable A. We can center that. Okay, so that's looking good so far. Now we can pattern all of this. Linear sketch pattern. I'm not going to worry too much about the distance. We're going to go with the number 12. And apply. And then what we're going to do is we're going to add in a solid line down here. And a solid line up here for our base. So the distance between these two is equal to 5. And the distance between, so we need to use a sketch point here at that intersection and that one. And we have here a global variable of C. Okay, so looking good. Now we can go ahead and power trim some of the stuff we don't need. So I'm going to start up here and power trim my way through a few of these. And hope my hand stays steady enough to not trim the wrong stuff. Okay, that's looking awesome. Confirm. and we can extrude to a depth of B, 80. Cool. Now to apply our material. So the material given is 1060 alloy. So we can go to edit material, 1060, which is an aluminium alloy. Apply, close, and we can get our mass properties. So head over to the evaluate tab, mass properties. We get a mass of 265.89 grams. So checking our answer, 265.89 grams. So part A, correct. Let's go back and update our global variables for parts B and C. So for part B, we have A is equal to 108, B is equal to 12, and C is equal to 1.5. Then hit OK. Our model updates, and we end up with this weird looking shape. Reminds me of Toblerone. Let's head back to our mass properties. 302.86 grams. Let's check our answer. 506.9. So in this case here, I know that the question or the answer, one of the two, is wrong, because our first part A, was 100% correct. Part B is way off the mark, and we didn't change anything within the model except for the global variables. So it's not possible that our answer is that far off. So in this case here, the answer for part B is not our answer. The answer given for part B is very far off the mark. So hopefully you got the same answer I did of 302.86 grams. Now let's move on to part C, and we can update our global variables. Head back over to our equations. We have 118, 14, and 2. Hit OK. More Toblerone. And mass properties. Mass of 441.67. And we get, again, an answer that's way out, which is not possible. So hopefully you got the same answers I did. And let me know what answers you got in the comments. Let me know if you enjoyed the video, and if you have any suggestions or critiques, please also let me know in the comments. I'd love to hear your feedback so we can improve the channel and give you the content that you need to get ahead. See you guys in the next video.